Two speakers emit sound waves initially in phase with wavelength equal to 0.21 meters. If a person walks from A to B, how many times will he experience deconstructive interference?
Okay, so this is the diagram we were given where it shows here's speaker 2 and here's speaker 1. So since we want to find this distance from speaker 2 to A, we need to use Pythagorean theorem, and we need to do the same thing from speaker 2 to point B. So we plug in for speaker A, it would be 3 on the vertical distance and 2 on the horizontal, and that gives you this distance to be 3.6. And then for speaker 2 to B, you would do the vertical distance is 3 and the horizontal distance is 8, so that gives you this length to be 8.5. Okay, so to find the path length difference, you need to first calculate delta RA. So that's the distance from speaker 1 to point A minus the distance from speaker 2 to point A. So that would be 2 minus the 3.6 we calculated, which gives you negative 1.6. And then the delta RB is the distance from speaker 1 to B, which is 8 minus the distance from speaker 2 to B, which is 8.5. So that gives you a negative 0.5.
So now that we've found the path length differences between the two, we can utilize this equation to find delta capital Phi, which is 2 pi times path length difference over your wavelength plus your delta little phi, which is like your initial phase shift. Our initial phase shift based on the question is 0, so that was given to us. So we're gonna find the delta capital Phi for both A and B. So using this equation with the wavelength that we were given and the path length difference that we were given, we get negative 15.24 pi. And then for B, you get just using the same thing like what we found for the path length difference in B over the same wavelength, you're going to get negative 4.76 pi. And then, so we go over here, kind of like create like a number chart. So this is at A to B. So you know that at point A, this is your phase, your delta capital Phi. So in between, you know that you're going to have any multiple of pi or negative pi. So we have from here, you're going to go from negative 15.24 pi to negative 15 pi. Negative 13, 11, 9, 7, all the way to 5, and that's the last one before you get to point B, which is negative 4.76 pi, and then all you have to do is count the deconstructive interferences in between, which we got 6.